vegetables you can get, and you make a stew out of it.
Gotcha. All right. Well, I have the spinny ball of death, so we'll see how this works, but that's on my YouTube channel, and it says it's going live, but I don't know if it is. Maybe I'll have to try that. I might try that on my. Good morning, everybody. Happy Monday. Sweet. All right. So for those that are on, happy Monday. Thanks, guys, so much for showing up. I appreciate you guys being here. We will go ahead and get started. I'm sure a few people maybe might jump in towards the end of our time. Let me see. Uh-oh. I just was lost from my Google Meets. So let's see if we can get back into that. People on the live stream on YouTube, can you chat with me to say that I'm good? All right, and I'm back. Let's see how this goes. Well, hey guys, hopefully you guys are doing well. Hopefully everyone had a good Thanksgiving. You know, it's crazy. We got about 14 days left of classes for this semester. So things are definitely going to go quickly. A little bit of update for us in terms of, you know, what things have been happening in class and kind of expectations for us from what we did weeks prior, or a few days prior to our midterm to today. So what we've been doing, obviously we had the midterm right before break. You guys had the group test on Monday, and then you guys started the corrections on Tuesday. Obviously I was not there on Tuesday. And so what I'm going to do is I'm going to allow you guys to turn in multiple choice corrections by this Friday. Okay, so there's no rush to get those to me right away. Those are just, you know, if you finish them on Tuesday and submitted them already, that's absolutely fine. But I'm not expecting everyone to do that so far. Okay, I know there's, you know, a lot of stuff going on. I know transitioning can be tough. And I know I haven't been here a lot over the last few days or last few weeks, just with me being out with my kids and stuff. So I'm flexible with that. So does everyone know how you can access your multiple choice questions to see which ones you got wrong, and the form. There should be a form on the schedule in terms of how to fill it out. Okay. Sorry, I didn't see that fully. Yeah, I mean, I would like them to have a mathematical explanation, but I know some of them maybe don't have the opportunity to, and so that's okay. But most of them should have an ability to work through that, and if they do, I would expect that to have them. Cool with that? But I understand some of them are just kind of factual questions, and so if that's the case, then that's absolutely fine. Okay. All right. So in addition to that, the free response questions, I'm in the process of grading. I have emailed a few of you in terms of answers to those or kind of your grading for that. I just haven't done it for everybody. So I don't really have a date in terms of when those corrections would be available. Okay. What I would say is they probably won't be due until next Friday. All right. So we'll probably have this Friday to work on multiple choice corrections. We'll have next week to work on free response corrections. And the goal is by the end of this week, everyone should have their, free response questions back to them. Okay. Questions with that? All right. Hopefully then the plan was going forward, the plan was that we were going to have a midterm, before winter break. I don't know if we're going to now or what that would look like. If we would, it wouldn't be a full midterm like we took right before Thanksgiving break. It would be more of like whatever content we've covered over the next 3 weeks. We would just take like a day to go through that just so we don't go on break and maybe not have an assessment on that. Okay. So that's kind of the plan going forward. Okay. Over the next few weeks, the goal is to finish up circular motion kind of this week. We have a new concept to add to it, and then kind of start into energy over the next 2 weeks after that. We won't finish energy, but we'll definitely have a large chunk of it done. Okay? Any questions from me? All right. Then my goal for today is to introduce us to a new concept, right? Dealing with this, so this is in circular motion, but the idea is like, why does the moon orbit around the Earth, right? What keeps the moon in a circular orbit, right? So it's circular, right? But what pulls the moon in orbit around the Earth? It's gravity, right? And the same idea is, so the Earth pulls on the moon. Does the moon pull on the Earth? Right? And people might say, yeah, I mean, and we know the moon pulls on the Earth because on the Earth we have tides, right? So our tides, high tide, low tide, right, is a product of the moon pulling on the liquid and moving it from one side of the Earth to the other, right? And so that's how we have tides. Which is greater, the Earth pulling on the moon pulling on the Earth? So I want you to raise your hand. So either virtually, there should be an option where you can raise your hand, or physically for those people that have their cameras on. Raise your hand if you think the Earth pulls on the moon more? Or don't raise your hand if you think the moon pulls on the Earth more, or do they pull on each other the same amount? Okay. And so what we're doing is we're just kind of getting an initial idea, right? We're stating what we think. Okay. Now, at the end of class, I'm going to share out a link to a great Veritasium video where he actually kind of goes through this. But what we're going to do is we're going to work through a lab today where you guys are going to get onto an online simulation and look at kind of how we might be able to answer this. Okay. So in Schoology, there under the Unit 3, there is a lab that is titled Universal Gravity. And on there should be a link to a PhET simulation. And so here's what I want us to understand. A PhET simulation is based off of like the physics laws. And so there's little to no error ever in a PhET simulation. So it's not really a great lab replacement because it doesn't give us the opportunity to make mistakes. But it is a good representation of what's actually happening, okay? Now, once I say go, I'm going to break you guys up into your working groups. So like A-Day kids, you guys are going to work in a breakout room. B-Day kids, you guys are going to work together in a breakout room. RLA kids, you guys are going to work together in a breakout room. And what I would encourage you guys is to, the goal for today is just to get through parts 1, 2, and 3. I don't have 4 quite done yet. So just get through parts 1, 2, and 3. And you guys are more than welcome. You're going to be asked to make a Google Sheet graph from parts 2 and 3. You guys can make a single Google Sheet and share it with the other people in your group, okay? But I want you guys to have, your mute off and kind of the dialogue on in terms of as you guys are working through this lab. I personally would not make a copy of it, right, virtually. I would just, in my notebook, Unit 3, lab activity, universal gravity, and just kind of make notes of what we're doing in your notebook, okay? Sketching the graphs, sketching the data tables. There's not a lot of data that you're going to collect. It's just more of looking at it and analyzing what's actually happening, okay? A few things in the simulation is we would want our masses. I'm trying to pull it up, sorry. So there's the data or the values are pretty much on there. A few things for you is when you are measuring the distance, you are measuring from black dot to black dot, or the center of each object. And then on the simulation at the bottom right, there's an opportunity to have a check mark that says constant size, where the size of the objects that you guys are going to be looking at don't change. I want you to click that so that constant size is on, okay? So I'm going to break you guys out into rooms. I can address small questions there. The goal for today is just to get through parts 1, 2, and 3. And then we'll probably work through part 4, the analysis, together as a group tomorrow. Is that cool? Okay, so this is looking at universal gravity. It's looking at the idea of how does the Earth and the moon attract each other? How does the Earth attract us? What is this idea of gravity? And can we expand it to more a universal idea of anything, right? Instead of just gravity here on Earth, okay? So go ahead and access that simulation lab. I'm going to break you guys into rooms and you guys can get started.
Mr. Ellis?
Yes.
I don't see where that simulation lab is.
It's in Schoology Unit 3.
Unit 3 lab, universal gravity?
Yep.
All right, thank you.
Yep. All right. I open the rooms. We'll see you guys. I'll pop into each one if you have questions, okay? Hey, hey, Brian.
Hello.
How's it going, buddy?
Great. I kind of did all my corrections on paper on the same page, so I'm trying to split them up. Okay, so how do I get into the breakout rooms?
I don't know. Let me see if I can figure that out. I think I can move you. Irshad, thanks so much for showing up. And I'm okay if this is working for you and not the Google Meets. Is there anything you have questions on? Do you know what we should be working on right now?
I have a question. Are the schedule times still the same for Emerald Campus? Because I'm using the normal bell schedule for that. I got emailed.
No, it's the same schedule as normal. So we're still going to start this class at 9:30.
Okay.
Okay.
Yep.
Brian, I think I can move you now.
Okay.
Enrique, I'm on with my physics group, buddy.
Oh. And bye.
I don't know if I can assign you somewhere, Brian. We're working through the lab in Unit 3 called Unit 3 Lab. Unit 3 Lab, Universal Gravity. Okay.
Okay.
Hey guys, just checking in. Any questions I can address right now? Okay, so again, as you guys are working, the goal would be you guys can talk to each other, work together, right? Ask questions, communicate, right? I'll be in the main call if you guys have any questions, okay?
Sounds good.
Sounds good.
Thanks, guys.
Hello, Mr. Ellis.
Hey guys. Any questions I can answer right now?
Well, yeah, no.
Okay, I'll be in the main call if you guys have questions, okay?
All right. It's good.
Thanks. Hey guys, just wanted to check in. Anything I can help with right now?
I think we're good.
Okay.
Thank you.
Yeah, I'll be in the main call if you guys have questions, okay? Brian, I think I made it so you can join the the breakout room now. Irshad, is there anything I can help you with? Okay. Hope the trip went well. And yeah, we'll just plan on doing the live stream like this each day. Okay. Or I guess I should talk there. I'm looking there, but you're there. So. Cool. And certain days I might save this live stream if we're going through content. I'm not sure how I'm going to be able to get, like if I'm writing on my whiteboard, I'm not sure how I'm going to be able to get that to you unless I do it, on the big whiteboard, which I might do. But if it just stays like this, I'll just delete this video afterwards because there's no reason for us to have access to it unless I'm delivering content. Okay. Awesome. It's always good to have a fellow physics professor to help. That's definitely a good use in the family. Hopefully I'll have to watch what I say now to make sure I don't make any mistakes. So. Hey guys, just checking in, seeing if there's anything I can help you with.
Oh yeah, Mr. Ellis, how do you multiply like the two columns together? Is it?
So if you have, a mass of 100 kilograms and a mass of 100 kilograms, you would just multiply those two together. So 100 times 100. So that'd be what, 10,000?
Yeah, I think so.
Yep. Cool with that? Yep, just the product, nothing fancy, just just the product like it asks for. Okay.
Yep.
All right. I'm jumping around. Again, I'm either in another room or I'll be in the main call if you guys have questions. And again, the goal is just to get through parts 1, 2, and 3 today. All right. If you don't get completely through part 3, that's okay. We can kind of catch up tomorrow. If you get done with that and you got nothing else, you don't need to wait for me to check in. You can just hop off and then we'll see you tomorrow. Okay.
Okay.
All right. But I'll check in with about 5 minutes to go in the class. I'll jump back into the groups and check in then. Okay. Hey guys, just want to check in to see anything I can help with. Any questions you guys have?
I like the equation in part 2, and I guess the equation in part 3 also. What is that symbol? Is that just like an infinity symbol? Or
yeah, no. So that's not necessarily an equation. That's a proportionality. Okay. So that's meant to be more of like these do not equal each other, but F is proportional to M1 times M2, right? So as the product of those masses increases, the force increases as well. It's not a direct relationship. That's what we're going to build into figuring out. But it's just showing that the product of those two masses, whatever those are, that's going to control the force in some way. And in this case, it's a direct relationship, whereas one gets bigger, the other one gets bigger as well. Okay?
Okay.
Cool.
What should we do after we finish parts 1 through 3? Just asking because we're almost done with part 3.
Make sure you have your Google Sheet, right? So, and again, it can just be one for the 3 of you. So make sure you have a Google Sheet for part 1 and part 2, equation of a trend line, and that. And then we only have about 10 minutes left, so there's nothing else that we can do. I'm going to check in with everybody about 5 minutes left in the class period. If you guys are completely done though, and you got nothing else, you're more than welcome to hop off and then we'll just talk through it tomorrow. Okay.
All
right.
Cool. Thank you.
Yep.
X is going to be.
It should be here for you if you highlight it.
X was product of masses.
That's fine.
All right, my B-dayers, how's everybody doing?
Good.
Good.
Line.
Questions with anything? Okay, so it sounds like you guys are making your first graph for part 2, which is awesome. Yeah, and it's the product, right? So M1 times M2, right? Make sure you're using those values. And then create a Google Sheet, get a trend line, get an equation of a line, right? And then as someone's doing that, other people maybe could be looking at, part 3 in terms of looking at distance and force, okay? That's our goal, is to get through part 3 for today. We got about 10 minutes left. I'll check in with you guys pretty much at 10:15. If you get done though before that, feel free to jump off if you are good. You don't have to stick around till that time, but that's kind of when I'll check in with everybody to end the day. Cool? All right. And I apologize for the weird sounds that the simulation makes, but it is what it is. So, all right, guys, I'll be in the main call if you need something.
Cool.
All right, Irshad, we got about 7 minutes left. I'm going to check in with the other groups one last time. Is there anything I can help you with before I stop the stream? All right, guys. Hey, we got about 5 minutes till we're out of here. Just doing one last check-in. Anything I can help with before we are done? right, I'm going to then jump into a different room. Hey, I appreciate you guys being here. Hopefully you guys had a great break. We will see you tomorrow at 9:30. Thank you.
Thanks. Bye.
Dude, that's 2.221 times 10 and a negative.
Oh, okay. I know what I'm doing because these are in fifths, not tenths. So 1 and 2. Okay. Right.
That isn't a half.
Yeah. No, you're right.
All right, guys. Excuse me. Hey, we got about 3 minutes till we are officially done. Anything I can help with before we're out of here?
The pattern for the equal distance when you increase by, or you multiply the distance by 2 each time, so you go from 1.1. For the last two, for the 4.4 and 8.8, there's a pattern there, but there's not a pattern for the 1.1 and 2.2.
I would challenge that.
I would too, because that doesn't match anything that we've seen before.
There should be a pattern. You should see now. It's not maybe not a clear pattern with this.
Yeah.
And so that's what we're going to look at when we graph it. Right? Is how can we analyze it? Because when you graph it, you're not going to get a linear graph. Right? So you should graph it, and you should get a graph that looks kind of like this. Okay. Once we graph it, tomorrow we'll walk through like how we can analyze this to make it a linear graph, to then be able to use that y equals mx plus b and get a better sense of kind of what that is telling us. Okay. Cool. All right. I'm going to jump off then. Feel free to join me in the main call if you got a question at the end of it. But hey, I appreciate you guys being here. I appreciate seeing faces, and we'll see you guys tomorrow.
Bye. Thank you.
See ya. All right, Irshad, I am going to jump off here. Shoot me an email if you have a question. Hopefully you have a great time with your family. Hopefully the trip there was smooth, and we'll see you tomorrow. I guess, what time is it there? Man, I'm curious. Shoot me an email with what time this is. So, hey, have a great rest of the day.
Sorry, who are you talking to?
Not you.
Oh, okay. Sorry.
It's okay. I'm